Remember, when we're multiplying and base is the same, we add exponents. Now, you will see that middle step. I'm just showing you that I am adding the exponents. A little later on, you'll see that I don't write that step anymore. It's just because it's new. You didn't have to write that step. What I'm interested in is that final answer of 3 to the power of 10. Okay, and remember, the exercise specifically said leave your answer in exponential form. So we stop once we get there. I don't want to know how much is 3 to the power of 10. Right? Any questions at A up until C? Yes.
I feel very dumb now, but weren't we supposed to like times the 3 times 3?
So basically, you first got the answer of 3 to the power of 5.
No, man, I just did 3 times 3 times 3, and then I got 9, and then I subtracted 5 plus 5.
No. Can I be the teacher? What you're getting confused with is this one, where we have a coefficient. So the coefficients, the 3 and the 7, I multiplied. But look at what happened to the a's. A to the power 3 times A to the power 6. The base stayed A. It's just the exponents I added and it became 9. Okay, so don't get confused. Coefficients we multiply, né? But in this case, we didn't have any coefficients. Our base was 3. So base stays 3. We just add the exponents. Okay. Long method. Just to make you see it maybe from a different perspective. And I'm not going to write that there because I've got space. 3 to the power 5 times 3 to the power 5. That is 3 multiplied with itself 5 times. So that's the same as 3 times 3. And you guys know a dot means multiplying, eh? Okay, so 1, 2, 3, 4, 5. So that's this one. And then times 3 to the power 5. So 1, 2, 3, 4, 5. So that's why my final answer is 3 multiplied with itself. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now it makes more sense. Does everyone see it? Okay. So base stays the same. So maybe, just so you guys know exactly what's going on, go back to what you wrote down yesterday. Over here, we said base must be the same, and we're multiplying. What do we do then? We add exponents. So all we do now is we add to that. NB exponents stay the same. Not exponents, sorry, base. Were there a lot of you that made that same mistake? Yes. Okay. Alright, can everyone put that extra bit at the bottom? Okay, can I carry on with the marking? Alright. You girls chatting away. Please make sure that you're busy with this. Okay, so hands up who's not finished marking up until 1C. Okay. Sorry? Yeah, you would have probably done the same thing throughout the whole exercise. So you've got lots of writing to do. Can I skip? Okay, right, there's D again. My base is 10. So my answer's base would still stay 10. All I do is I add the exponents. So 9 plus 11 plus 10. means that my final answer is 10 to the power of 30. Okay. Now, there's one exception here. Okay, so base over here is minus 3 in both instances. So base stays minus 3, and then what I did is I added these two exponents. The 2 plus the 3 gave me that to the power of 5. Now, if you stopped here, it's still correct. It's fine. But just to show you, if I were to get rid of those brackets, a minus multiplied with itself 5 times, because it's an uneven number, my final answer would also be a negative. Okay, but you didn't have to write that last step. Any questions there? Yeah. No. Okay, then at B, a to the power of 4 times a to the power of 6 times a to the power of 8. Base is the same, and we're multiplying, so base will stay the same, a. I'm now going to add my exponents, and 4 plus 6 plus 8 will give me a to the power of 18. Okay, any questions? You guys are busy with other work. It's not math. Can I skip? At C, my base here was minus a. Because that bracket was around it, it means the whole thing would be my base. Now look at that last term. Minus a, and then you'll see in yellow, I filled in to the power of 1. Because if nothing is written there, it's actually to the power of 1. No? So if I go add them, my base would stay minus a, and then the 5 plus the 3 plus that 1 means that my exponent will be to the power of 9. Again, you could have stopped there, but if you maybe went further and got rid of the brackets, a minus multiplied with itself 9 times, again, it's an uneven number, so your final answer would still be a negative, and then a to the power of 9. Okay?
Ek is op soek na moeite van F 10 of 4 as 'n lossing besluit weet my net seker. En Stefan Ritter, waarskynlik met ons op kantoor se kom asseblief dankie.
Okay, and then at D, over here, I've got a base of y. Over there, my base is minus y. So could I go and add those exponents? No, because base is not the same. So then we use BODMAS. I first got to get rid of the brackets here. So minus y to the power of 6. That to the power of 6 applies to everything inside the bracket, meaning the minus and the y. And minus multiplied with itself 6 times. Because it's an even number, it will give me a positive answer. And then y to the power of 6. Who doesn't understand that part? Sorry? You're going to get a mark for that. And you could not go from here to there because you had to show me, because bases aren't the same. Yeah, and there. You've got to have your bases the same first, and then you can go and add. Sorry, her hand was up first, yeah? The y was in brackets and the minus was outside. Oh, same thing, yes. Yeah. What if it wasn't? If it's an uneven number, then your answer would be a negative. So it would look like this, negative y. And then your answer would be minus y to the power of 30. It's fine. Right, then number 3. Over here we actually have coefficients. So I first multiplied that 4 and the 5, and that gave me 20. And now I look at a to the power of 2 times a to the power of 1. No? And because base is the same when we're multiplying, I can add these exponents. And that's how I get to 20, a to the power of 3. You guys good? Okay, can I skip? Okay, so there's B, C, and D. Same thing. First multiply your coefficients and then look at the bases, whether they're the same, and if they are the same, we add exponents. At C, this added step, you did not have to write. I'm just showing you. Okay? Can you see I only add the A's exponents? So A to the power of 2, A to the power of 3 will become A to the power of 2 plus 3. No. And then I look at all the B's because I can only group together those that has the same base. B to the power of 2 times B to the power of 6 will become B to the power of 2 plus 6, meaning B to the power of 8. Any questions? Yeah. Say again?
Oh, can we just go to 3D quickly? I just want to see. I don't know.
D. Yeah? Okay, let's first look at the coefficients. 2 times 3 gives me 6. Times 4 gives me that 24. Now, okay, now look at all the A's. A to the power of 3. A to the power of 2. And that is actually A to the power of 1. So because base is the same and we're multiplying, I can add those exponents. 3 plus 2 plus 1 means it would be A to the power of 6. That's what you missed. No? Yeah. Are you fine with the B's? Okay. Anyone else? Right. Can I skip? Okay. So now we are busy with law number 2. Now, law number 2 is about dividing powers. Okay, so we have almost the same steps. Firstly, the bases must be the same. Second, we must be dividing. And if those two are true, then we are allowed to subtract exponents, but only those that has got the same base. No? Subtract exponents. Very important, we always take the top exponent, meaning the one at the top of my fraction, minus the bottom exponent. You'll see what I mean just now when we do the examples. Any questions? Maybe just let's write base stays the same as well. Right, you guys done? Can I skip? Hands up if you're still copying. Right? Okay, I'll show you just now when we do the examples. Usually when it's division, we can write it as a fraction. So let's say a to the power of 4 over being divided by a to the power of 2. So then the base is the same, and we're dividing, so then I take top exponent minus bottom exponent. But you'll see when we do examples. Yeah.
What row number is it?
2. Right, everyone finished copying? Okay, so let's look at the examples. Number 1, a to the power of m divided by a to the power of n. Can you see that base is the same for both of those? Both have got a base of a. We are dividing, so that means we can subtract exponents. So your answer will be, remember base stays the same, so still a, but now at my exponent I'm going to have m minus n. Does that make sense? Right. Let's look at number 2. 7 to the power of 12 divided by 7 to the power of 7. Is my bases the same? Or are my bases the same? Huh? Yes, they both have a base of 7. And we divide it. So that means base stays 7. And I'm going to say 12 minus the 7. So your final answer will there be 7 to the power of 5. Yeah.
Say it's not like divide or times, say it's base with the exponent minus base with the exponent. You first simplify that. Or first add.
It's a bit more complicated. You're going to factorize to make it one term, but we're going to get to that end of the chapter. That's fine? No, it's fine. Okay, so any questions so far? Okay, now, number 3 is what I was talking about just now. So can you see, instead of writing it x to the power of 6 divided by x to the power of 2, I give it to you in the form of a fraction. No, but it's still, so you could, don't write this, I'm just showing. That's the same as x to the power of 6 divided by x to the power of 2. No, we're just giving it to you in a different form. So, if that is the case, then is base the same? Yes. Are we dividing? Yes. So what do we do with exponents? Minus, and this is where I'm saying top minus bottom. So top exponent was 6 minus bottom exponent of 2. So your answer will be x to the power of 4. Does it now make sense? Good. Okay. At number 4, what I did is I put in coefficients as well. Now, let's say, forget about those A's. Let's say you only had this. 56 over minus A. What would you have done? We simplify by seeing what can divide into both the top and the bottom. No? Do you guys agree? Okay, and that's going to be how much? Negative? No, okay, forget about the A's. Negative 7. Now, if I just look at the numbers, 56 over minus 8 is going to give you minus 7. Okay, now let's look at these. A to the power of 5 divided by a to the power of 2. Is my base the same? Yes. Are we dividing? Yes. So what do? We're going to subtract exponents. So that would be base stays a. I'm now just going to take top exponent minus bottom exponent. Do not switch that around. People, sometimes your top exponent is less than your bottom one, meaning you're going to get a negative exponent. That's not wrong. We can get that. Okay, we're working towards that little later on. Okay, so that's why I'm saying, remember, always take top exponent minus bottom exponent. If you do it other way around, it's going to be wrong. So your final answer here will be minus 7 a to the power of 3. Okay, any questions? If you're comfortable with it, you can skip directly to that final answer, eh? Okay, Last one. Can I skip? Yeah? Oh. Hands up, you're still copying? Okay, last one. Because of that recording sign, I'm going to write at the bottom. So, x, y to the power 4. Can you see that it's put in brackets? Right? So that to the power 4 applies to the x and the y. Now, at the bottom, I just have xy. What is my exponent there? That's actually a 1. So, is my base the same? Yes. Are we dividing? Yes. So, base will stay x, y. Now, just trying to find out, what do we do now with exponents? We minus. So, I'm going to take top one minus bottom one. Is this correct? What's missing? The brackets. No. Why do I have to keep brackets around it? Because without the brackets, like you see it on the screen there, this exponent only applies to the y. And it's supposed to apply to the x and the y. So do not forget your brackets. Okay. So your final answer will be xy to the power of 3. You want to go a step further? X to the power 3, y to the power 3. You could, yeah. Okay. Any questions? Are you guys sure you understand? Okay, then your homework is exercise 5.2. That's on page 43. You're going to do number 1 up until 3. Okay? Right.